Hi, I'm Mackenzie Bussel from Group 4, and today we will be presenting our Blackjack player through OpenCV. So we're going to do the live demo first. I actually got it to work, Mirza, so we're okay. I don't know what was wrong with my C key, but I just changed it to the Q key before this started, and it works fine now.
But before that, Mackenzie, can everybody in the group introduce themselves and talk about the project, what we are going to see?
Yeah.
Go ahead.
Hello, everyone. I'm Jacob Zamboroski, and I work in this group as well.
Hello, I'm Amal Baiz.
Hello, I'm Lucas Serowoky.
I think that's everybody. So I'll go ahead and explain what the game is supposed to do. So essentially, we'll put some cards under a camera like this. Can you guys see that well?
We can see it.
Okay.
Yep.
And so we put the cards under the camera, and then what we'll do from here is we will just capture images. So it popped up in my other monitor. So it takes a picture and it shows you what cards are laying down, and then it actually processes the image and thresholds them. And then, sorry, it's kind of hard to move these windows around. Okay, that doesn't matter. It's two little pictures. So actually, here's the program working. It'll identify the card and show you what card it is by drawing the name on the card, and then it'll outline it with a bounding box. And then we have a running sum that is displayed up in the top left corner. And if you win, then it'll tell you your winner. But I guess I can also show a condition where the user would lose. So if you hit yes, we can play again. And now we have 3 cards. So go ahead, capture a picture of those. It did not recognize the king, probably because of like the reflection or something. It's very, very fragile sometimes. So actually now that it didn't even recognize the king, we have the option to hit or stay because it thinks we only have 19. See, okay, there we go. Worked this time. So this would be 29. So the user would actually lose the game, and then they have the option to play again or not play again. And if they hit no, then the program just exits itself, and the user can play again whenever they want. We were gonna implement like a card counting system that actually give you tips and probability about what cards to like whether to hit or stay, whether you had a certain sum. But with the time allotted, the algorithm for card counting was kind of difficult, and so we just decided to go with this since this worked. We could probably, Amal, do you want to share your screen now, and then we can do the actual presentation, or should we do the recorded demo?
Yes, go ahead and show the recorded demo also.
Okay. See, I'll just mute it. So this is the recorded demo. It takes me a second to actually put down some cards. So here I put down a king and an ace. So this would be our win condition for just 21. We also programmed the ace so that if the count is greater than 10, or if it's equal to 10, or no, if it's greater than 10, that the ace will be if it's greater than 11, I'm sorry, the ace will be 1 instead of 11. So what happens is we basically capture the image, and then the computer will show us what it sees and what it grabbed. We have the program basically taking thresholds of the images and then finding the contours in that. And then when we find the contours to determine whether it's an actual card, we if we determine that it's a card, we grab the top left corner and zoom it in and then try to find contours that are matched to images that we have uploaded. We'll show you that in the presentation. But basically it tries to match the two images together. So using contours. So here's a condition where you don't win and you don't lose, so you can hit or stay. And then this would be the condition where you lose. And then I think that's it for our live demo. Okay, so this is the introduction for our card playing game. We decided to do Blackjack because we thought it would be a fun, easy game that everybody loves to play, and that we could actually teach the machine to, count cards, which we didn't get to, but we thought it would be a great idea, and it actually turned out really well. Next slide, Amal. So this is like the bread and butter of our program. We basically found 13 images on Google. I found it on, I referenced the website in the end, but essentially what our program does is it'll import these 13 images and we put them into an array. And then when we take pictures of our cards, it will take the picture of the cards that we've captured, and it will threshold them and then find contours in them, like I said. And then if it determines that it is a card, it will grab the top left corner, and then it will basically go through all 13 of these in the array and try to see like which one is the best match. If it can't find a match, it'll just display a question mark on the actual card itself. But yeah, so press C, but we actually had to change that before for some reason. I guess C decided to stop working today for presentation purposes. Next slide.
So for the webcam display, we had a tripod set up. The webcam we're using is the Logitech C920. It's important that we had that tripod there. That way someone doesn't have to hold the camera themselves, which would be unsturdy, or if someone like on a laptop webcam, that would make it difficult to hold the cards up and then the background would be moving. And yeah, we have a live stream of the webcam and the display sequence. So it shows the original image like you saw, and then it converts it to binary image. And then for those of you that aren't familiar with Blackjack, the point is to get to 21 points, and the dealer's playing the cards also. And so the card values 2 through 9 are their face value, and then Jack, Queen, and King are worth 10 points. And then you can use an ace. I think Mackenzie was saying this before. It can be either a 1 or 11. So it's a little background of the game for that. And then it'll display the total value of the cards. And it shows, there's a little bounding box around the card to parameterize that. Next slide.
So after C is pressed and the image is captured, it identifies the rank of each card based on the predefined rank images that we placed into the code, and it displays the rank on top of each card as shown in the image. Each card is assigned a numerical value. So as we said before, the picture cards, the Jack, the King, and the Queen are assigned a 10. And an ace can either be a 1 or an 11, and the number cards are just the value of the number. And then the code sums up all the numerical values and displays it in the top left corner of the screen. The goal of the game, as mentioned, is to get a sum of 21. As mentioned before, the sum is displayed above next to the message that the program wants you to see. It decides the best action to win. So for example, as we showed in the demo, the ace, the computer assigned a value of 11 for the ace, so it can have a total sum of 21. So it won because of that. There's two display conditions. You're either a winner or a loser. If you win, you get a sum of 21. If you lose, you are over a sum of 21. If you have a sum less than 21, it will ask you to hit to draw another card or to stand. If you do choose to hit, then it will add the value of the new card to your sum. After the game is over, it will tell you if you want to play again. If yes, you press Y. Then the game resets and the count also resets.
Sorry, that was my turn. So this is a flow chart of our program. So essentially, step by step of how it works. So the cards would be dealt. The user would press C to capture an image of the cards. And then once that image is captured, it will process it and threshold it to find the contours of the card. And then if the sum is less than 21, it will ask the user if they want to play again or if they want to hit, actually. And if they do, then they'll draw another card, and then that card will be added to the count as well. But if they hit no and the sum doesn't equal 21, we just decided for the simplicity purposes that the user would just lose. But if they do have 21, then they're automatically a winner, and then they have the option to play again. If they hit no, the program will close out. But if they hit yes, the program will basically just reset the count, and then the user can draw new cards. Next slide.
Hello. So some future additions that we wanted to add to this project, but they were a little too difficult to implement with our given time frame. First, we wanted to implement a probability meter. This meter would pop up on the side of the screen and display the probability of a win or a loss to help a user decide the best course of action he should take with his hand. To gauge the probability for this meter, as Mackenzie had mentioned earlier, we wanted to count the cards in the deck. We would take into account all 52 cards which are present in the deck, and through each hand that is played, it would take the previous hand's cards out of the deck, and this would help display a more accurate win-loss probability for future hands. For this meter, we also wanted to implement the dealer's hand. It would be beneficial to implement a second hand on the screen to represent the dealer's hand, as the probability of the user can change greatly based just upon what the dealer's cards are. Sometimes it would make more sense to stay, but if the dealer is tied with you, you would have to hit or you would lose automatically. We also want to include more decks into this application. It just uses the one deck. And the reason we want to include more is because there's many different types and styles that are out there. Next slide, please. So in conclusion, Blackjack is a very popular game that many people would like to get better at. Our program uses machine vision algorithms to see how each hand should be played by the user. Our main goal is to make users better at this game so that they can win more often and they can go to the casino and they can win more money. Next slide. Here are references. Does the audience have any questions for us?
Thank you, Group 4. That was a great presentation. I have to tell the whole group here and our guests that the students only had 2 weeks to come up with the idea and decide what they're going to do and actually implement this project. So they had very limited time. I know some of you had very ambitious ideas and you were not able to implement everything. We understand that, but as long as you have this is what I can do if I was given enough time, that's great. And whatever you guys did is fantastic within this short time. And also, this is the very first computer vision course these guys are taking in their bachelor's. So kudos to every one of you that you did come to this speed and have a practical working demo. It's a huge deal. Anyway, all right, we're going to open up for questions. If anybody has any question, please go ahead and unmute your mic and ask a question. I do have to say this will be illegal in Las Vegas if you implement the counting system for the cards.
That's why we put the disclaimer. So that
Yeah, I'm glad you guys did. So
I have a question.
Go ahead.
Team 4, does the orientation of the card matter? I mean, if you put them sideways, would your vision program still pick up the value?
Yeah, I didn't even actually think to show that. It actually does. We had to actually implement an entire, like, I don't know, it was a huge block of code basically just to like determine whether the card was sideways or if it was just a regular side vertically. I should have showed that. Sorry, I didn't. I forgot to include that.
No problem.
So which algorithm did you use, Mackenzie? So I'm assuming it's a rotation and scale invariant matching. So do you know which algorithms you use for matching there?
You mean matching the cards?
Yeah, the value of the, when you're trying to recognize what face value the card is.
We actually just used, it was an OpenCV function. We basically just took we called them trained images because we considered we were like training the computer to like look for these images. We basically took that and then the corner that we zoomed in on, and OpenCV has this function that's like an absolute difference. And we took the absolute difference of those two images together. And then if the difference was too high, then we didn't even consider it like a match. We said that can't be a match, that's too different. And then for ones that were like within, I had to mess around with the numbers quite a bit. That was probably one of the most challenging parts, was finding what numbers were safe to stay in between. So if the absolute difference is between those values, then it actually recognizes that it's that card.
Okay, sounds like it's a machine learning algorithm then. It's basing it on those algorithms. That's great. It does look like it worked very well. Any other questions from anyone?
Yeah, real quick. What would happen if the cards are touching? Would it detect that as two separate cards or one blob?
You know, we actually didn't test that, but more than likely it would not detect it because basically how our program works is it'll take the image of like the table that you're playing on, and then it'll try to find like the edges of the cards, but like it'll take the contours of the images that are threshold, and then it'll like try to find each individual one. And we also had to give each actual card its own dimensions as well, so that when we were doing the contours, we knew like what kind of area to look for. So I definitely would throw it off.
That was a really good question, Alex, because if you're using simpler algorithms like blob detection, then touching cards will be one big blob, and then you're trying to figure out what is this. So if you're doing a more of a shape matching algorithm, then it will recognize even cards which are on top of each other. So good question to make it more robust. How about the grayscale level? You said you had issues when the lighting was a little bit different. It wouldn't recognize it. Is there a way to automatically adjust the grayscale so you can try a few values and see where you can recognize an image?
Honestly, I didn't think of that. And what I did was I basically just sat in my room and messed with the threshold values until I got like a good looking threshold image. So that would definitely be something we could improve upon in the future because, not everybody's going to be playing blackjack in my room. So they might, have different lighting conditions like overhead light or light coming in from the side. And they might have a brighter room than me. And then that would throw off the threshold values a lot because that was something we struggled with trying to get to work for a while. We couldn't even recognize any cards because our threshold just looked like a white blob and they didn't have any letters on it at all.
Great. Yeah, these are all very practical problems when you're doing any kind of machine vision in the field. Lighting control is a huge issue there. Any other questions from anyone?
Yeah, Team 4, did you have a challenge whether you're dealing with red cards or black cards? Did the colors pose a problem for you?
You go ahead. Go ahead. Sorry, I had two computers and it started echoing. That was weird. Yeah, no, we actually didn't have a problem with red or black cards because what we did was we basically took the image in and we converted it to binary. And since we converted it to binary, the shades and the values of the white and black might have been a little different, but they were so little that it was insignificant. So we didn't have to consider that.
Great. Any last questions for the group?
What was the most interesting aspect of the project?
Getting done.
I would say just the future ability, just be able to be able to count card count and show the dealer's cards. There's a lot of room to improve on here, but I mean, we were happy with being able to detect the cards and the lettering on the cards. So there's a lot of room to improve on here for future editions.
Yeah, I definitely think that like the most interesting thing to me was like learning how to actually detect certain objects because I like features of an object because like that was definitely a struggle for our group. We weren't sure how we were going to approach matching individual features on a card. So that was definitely the most interesting thing to me because we are in a machine vision class and it's awesome to see how we can take the things that we learned in class and apply them to an actual program.
Great. Thank you very much, Group 4. Great job again. Awesome.